Hi, class. This is 15.3, ranges and standard deviations. A range is the largest number minus the smallest number in a set of data. Your interquartile range, also known as IQR, is the third quartile minus the first quartile you need. And this is what we introduced in 15.2. It's the third quartile and fourth quartile. We're referring them back to them now. The interquartile range represents the middle 50% of the data. Something new here is your variance, which we're going to use the capital letter V. It is the square. You square the difference of each data point D from the average A. So it looks like D minus A. That's what the difference means, subtract between the two. And then you square it. That's what they say, square the difference. So square the subtraction of the data point and the average. And then, so when you do that for all the data points and then average these numbers. So we'll find the variance in a problem. Then the standard deviation is just one more step. You take the variance and you take the square root. And they like to use this little, it looks like a circle with a little loop on the top. Or I don't even see a loop, but it kind of looks like this little circle with the line on top, I guess. Okay, that's sigma. They like to use that for standard deviation. They also like to use in research papers the capital letters SD for standard deviation. Just, you know. All right. So the following questions refer to the number of units taken by students in a class. So remember last class in 5.2, I pretended like I was asking everybody the number of units that they took in the class. I wrote down how many units each student was taking, and that was called the data. When one single answer from one single student is called a data point. And so this is all the data that was collected from me asking how many units do you guys each take. So they asked me, what is the range of this data? So the range it's the easiest thing to calculate, I think, because it's just your largest. So we look, and then since we have these data listed from smallest to largest, it's just the one on the end here. So it's 18. So see how I have the data listed already from smallest all the way up to greatest. So just the one that is on the greatest here is 18. It's easy for me to find. And the smallest data value is 3. So I just subtract those two. I took the largest data value. And I subtracted the smallest data value. And that's what gives me the range. So 18 minus 3, it's 15. And so 15 is the range. All right, what is the interquartile range? The interquartile range, looking from above there, is the third quartile minus your first quartile. So looking back on the work that we did in 15.2, we found the first quartile was 6. And the third quartile was 12. You can remind yourself of how we found those by looking at the 15.2 lecture. Anyways, all I have to do here is subtract them. Our third quartile is 12. I plug in for 12 for Q3. And I plug in 6 for Q1. 12 minus 6 is 6. So our interquartile range is 6. The semester grade in a class in statistics is determined by the scores on 5 100-point exams. Steady Susie scored 82, 82, 81, 82, and 83 on the 5 exams. Erratic Ernie scored 59, 73, 82, 97, and 99 on the 5 exams. Calculate the mean and median for each student's grade each student's exam grades. So for Steady Susie, or Sue, we're just going to add together, and it's a little easier if I just arrange these from smallest to greatest, but it's 81, 82, there's 1, 2, 3, 82. So it's 82, 82, and 82, and 83. If we want to find the mean or the average, we add them all together. And I got 410. And then you take that sum, because we're trying to find the average, so you add all the numbers together and then divide by the number of numbers. So I'm adding 1, 2, 3, 4, 5 numbers. Look at how, see, I'm adding 1, 2, 3, 4, 5 numbers. So I'm going to divide by 5. So that gives me a mean of 82 for Susie. So Susie's mean is 82. Then we can also calculate her median. And the way we would do that, I'm going to erase this. Hopefully you guys got it in your notes. You know how we got that mean. But then how we would do it if we I'm going to ignore the positive signs, but if we were trying to find the median, I would cross out the top and smallest and largest, and a second smallest, second largest, and then my median is 82. So her median is also 82. All right, so next I'm going to calculate for Ernie his mean and median. So I'm going to try to get them from smallest to greatest. They already are. Anyways, to find the mean or the average, I add them all together. That's 410. And then I divide by the number of numbers, which is 5, and I also get 82. So Ernie's mean is 82. And next, I I do the same thing I did a minute ago with, and to find the median, I cross off the smallest and largest, and I get the middle number is 82. So actually, for both students, they have the same mean and same median, if we notice that. And but yet their scores there are very different. What we're not really taking into account when we calculate there's the mean and median is how widely spread out the data are. Because as you see with Sue, she got really close to 82 on nearly every score, every test. And Ernie, there's lots of variation, but if we just calculate the mean and median, we don't see that variation in the data. So there's two things that help us to see how spread out apart those data values are from each other, and that's the range and standard deviation. So they want us to find, that's the next parts here. It says in part B, find the range for each student's score. So let's work with Sue, sorry, I'll call her Susie. Her range is her largest data value, which is 83, minus her smallest, which is 81. So her range of data was 2. Ernie, his largest was 99 and his smallest was 59. So his range was 40. So this describes to you, what the range is telling you is it's at one number that it's helping us figure out how far apart the data values are, how his test scores were, right? And now the standard deviation is another number that also does the same thing, that shows us how well spread out the data is. So let's just look back here. They say to find the standard deviation, we have to first find the variance, and you square the difference from the data point. From the data point is from the mean or the average, and square it, and then you take the mean of all those numbers, the average of all those numbers, and then we're going to take one more step and take the square root to find the standard deviation. So let's see how that looks. For Sue, I'm going to do this D minus A. So D stands for data point. So I'm just going to go down the list of her different test scores. But the first test score was 81 minus the average, her mean was 82, which is the same as Ernie's mean. That leaves -1. Right? And then the second test score was 82. So the second data value point is, so maybe, before I start doing this, I'm going to add one more thing on here. I'm just going to take all her test scores and list them. Those are the data values for Sue. So it was 81, 82. Let me try to move this up a little bit. I have a feeling we're going to need this space. So those are her different data test scores. Now we're going to calculate D minus A, which is the data value there, which is 81, minus the mean, which we saw the mean up here is 82. So minus 82. Then we take the second data score, which is 82 minus 82. And then it's 82 minus 82 again, the third data value. And then the fourth is also 82, so it's 82 minus 82. And then the last one is the data value is 83 minus the mean, which is 82. So I get -1, I get 0, 0, 0, and +1. Okay. Then the next thing we have to do is we have to square this difference. So I'm going to try to just write this really tiny, like D minus A squared. So it's -1 squared. It's 0 squared, 0 squared, 0 squared, because I already did the D minus A. So I'm just putting that answer in parentheses here for D minus A and just squaring it. And then 1 squared. And -1 squared, this is a mistake that a lot of students make. See if I can draw this in a little bit closer. A lot of students make a mistake here, -1 squared. That's -1 times by -1, which is a +1. So anytime actually we square a number, the answer is always positive. So this is +1. This 0 squared, well, actually, except for 0, right? 0 squared is 0, and it's not, we don't call it positive or negative, but okay. Then 1 squared is 1. Then the next thing we do is we sum up all these squares because we're going to take the average of them. So 1 plus 0 plus 0 plus 0 plus 1 is 2. So the variance is the sum of those D minus the differences minus the average squared all over the number of data values. Because that's the number of numbers that we added together over here. 1, 2, 3, 4, 5, 1 plus 0. It's another way of saying it. And so our sum is 2, the total number of data values. We could see the test scores. There was 81, 82, 82, 82, 82, and 83. So there's 5 data values. So, or you could just say we added 5 to get numbers together over here when we're adding up these squares. However you want to think of it. Anyways, the answer is 0.4. So our variance is 0.4. Then the standard deviation is equal to, so this is Sue's standard deviation. That's really the question they wanted us to answer here. It's a square root of 0.04, or 0.4. And so I took the square root and I get 0.63. Oh, and they say do 2 decimal places, so 0.63. And there we go. That is Sue's standard deviation. There we go, right here. All right, now we have to do this process for Ernie. So his data values are 59, 73, 82, 97, and 99. Then his D minus A, his average or mean also up here, you could see it, his Ernie's mean is also 82. So we're going to do 59 minus 82, 73 minus 82, 82 minus 82, 97 minus 82, and 99 minus 82. All right, and then I calculate those differences. I get negative 23, negative 9, 0, 15, and 17. All right, then they want us to take that, the D minus A responses that we just got, and square them. So we're going to take the negative 23 and square it. Like I said, a negative number squared is going to be a positive number. So I get 529. Then negative 9 squared is going to be positive 81. 0 squared is 0. 15 squared is 225. And 17 squared is 289. All right, then V is the sum. So we're going to add down this column here. So the 529 plus the 81 plus the 0 plus the 25, 225 plus the 289. I add up all those and I get 1,124. So that is the sum of the D minus, they call the D minus A a deviation. So deviation squared. Deviations, the sum of the deviation squared divided by the number of data values. Number of test scores in this case, because data we got from him was his test scores. And that is the sum of what we got down here is 1,124, the sum of the deviation squared. Then the number of data values is the same. So he has 59, 73, 82, 97, and 99. That's 5 numbers. So divided by 5. Also, you could think we added together when we came over here, we added to get this sum. We added 1, 2, 3, 4, 5 numbers so that you could just remember that's why we were dividing by 5 here as well. Anyways, I do that division. I put 1,124 in my calculator and I get divided by 5. And I got 224.8. And that's for our B variance. Next, we take the square root of the variance, which is square root of 224.8. You can find this on your calculator. You should look for a little like button that looks like that. Sometimes it's on mini calculators, it has an x squared, and then that little sign is above it. It means that you have to press second on the calculator to get it to, and then the x squared button to get it to do the square root. You do have it on your cell phone calculator, a square root symbol, but you have to turn, if you have your calculator you have to turn it. Okay, so if you have your calculator, your cell phone turned this way, what you have to do, you have to put it in calculator mode and you have to turn the calculator, your cell phone this way, and it'll show you a lot more options. And one of the options it gives you is a square root. And I believe it looks like this and it has like a little 2. So the little 2 being there means that it's a square root, and that's the button that you want. Okay, we're calculating that square root. Anyways, we take the square root and we get the answer 14.99. So that is Ernie's standard deviation, is this 14.99. And you notice it's a lot larger than Sue's standard deviation, and that's showing it. It shows it's a lot larger because the data values are a lot more further spread apart, and that's what that means to us when we have a larger number for a standard deviation. And we can think of a standard deviation as a typical distance that a data value is from the mean. So it's just, I'm going to erase. I mean, this is what we did to find it, but the actual answer is 14.99. And also the same thing up here. I'll do this. We did the square root of 4 to find it, but the actual answer is sigma equals 0.06. 0.6 or 0.63. That's what I meant. Okay, there you go. There's your 2 answers. All right, moving on to the next problem. The table shows the ages of local business owners in a town. So here, all of this data is summarized in a table for us. And okay, let me read it again. The table shows the ages of local business owners in town. So what it tells us is the frequency, the age is 24. The age here is 24, and the frequency 2 means that there was 2 business owners who were 24 years old, right? And there was 8 business owners who were 26 years old, 6 business owners that were 28 years old, 8 business owners that were 29, 15 that were 30, 13 that were 31, 7 that were 32, 9 business owners were 33, 7 business owners were 36, 4 business owners were 38. So that's the results of their study. They ask us, what is the minimum age of a business owner? Well, it's pretty easy for us because it looks like these numbers, 24, 26, 28, 29, 30, 31, 32, 33, 36, and 38 are all listed in order from smallest to greatest, as they usually are in a chart like this. So we can just look at, I just go to the very beginning of the chart, very first age that I see, and because they are in order from smallest to greatest. This is our smallest age, the 24. Do be careful, because even for me, I have trouble with this too, that for whatever reason, I want to say my youngest age is 2 because that's the smallest number that I see in this chart. But remember, they're asking us for the age, and these numbers on bottom, the 2, 8, 6, 8, those are the frequency. Those are not the ages of actual business owners, because I don't think anybody owns a business at age 2. Anyways, that is easy to confuse here. Anyways, the minimum age is 24. What is the first quartile? So we're just going to use what we learned last time. The first quartile is we're going to find it by doing, it's the 25th percentile. So it's 25 over 100 times by the number of data values here. So what we need to do to find the number of data values is we have to add together all the frequencies. And we get a total over here. And that total I got is 79. Okay, so I do 25 over 100 times 79. And I get, and that actually, 25 divided by 100 is 0.25 times by 79. And that number is 19.75. Which we need to round it up. So it rounds to 20. Remember, if it's not a whole number, we round it up. All right, so what that means for us is we need to go down and we need to say, okay, the first 2 people answered they were 24 years old. Then the next 8 answered they were 26. So that took up the first 10 people. So they were 23, 24, and 26. Then if we add 6 to that, that would get us to 16. So 16 people answered between 24 and 28. We're looking for the 20th person in line. Remember, we have to line up the data values from smallest to largest. Well, they're already kind of lined up from smallest to largest because the 24 is farthest to the left here, the 26 is next, and so like that. But they are listed in their frequency, so I have to think about it kind of a little bit differently. Instead of just counting down the row, I'm still counting down the row to get to the 20th person in line. But the first 2 people in line, so they're 24, then the next 10, the next 8. So that was 10 people in line, the first 10 people in line. Then if I add 6, that's the first 16 people in line. Then if I add 4 to that, that means the fourth 8, that is, I mean, there's 8 people who answered 29. The fourth 29 is going to be our first quartile. So the answer is 29. All right, then it says find the average age. Round to 2 decimal places. So to find the average, I have to add up all the numbers. So I have to add up, oh, wait. To find the average, hold on. Remember, when you have it in a table like this, there's 2 people who are age 24, 8 people who are age 26, and so on. So how we're going to do this is I think about multiply the chart, we'll multiply through the chart, and then we're going to sum up. Okay, so we're going to multiply down because we have to add up all of the ages and divide by the number of people who were surveyed in this survey, which you already said was 79. But I'm going to multiply down. So 2 times 24 is 48. 26 times 8 is 208. 28 times 6 is 168. 29 times 8 is 232. 30 times 15 is 450. 31 times 13 is 403. 32 times 7 is 224. 33 times 9 is 297. 36 times 7 is 252. 38 times 4 is 152. And now what we have to do is we have to add these all together. And the number I got when I added them together was 2,434. And now I have to divide by the number of people who responded in this survey, the number of people whose ages we just added up. And that is the sum of the frequency, which is 79. So we have to divide 2,000. So remember the 79 I got from adding up all the 2 plus the 8 plus the 6 plus all the frequencies together to get 79. So that is the number of people who own a business and gave us their age in this survey. So we just added up all their ages. We got 2,434. Now we divide by the number of people whose age we collected, 79, and we get this 30.81. So I did 2,430 divided by 79 and got 30.81. And that is my average. Then they say find the median age. Well, to find the median, we could do 50 over 100 because it's a 50th percentile times by 79. That is 50 over 100 is 0.5 times 79 is 39.5, which rounds up to 40. So I need to find the 40th person in line. So here's the first 10 people in line. So 10 plus 6 is 16. So here's the first 16 people in line. I'm trying to find the 40th person in line. Plus 8 here is going to be 24. Then plus 15 is going to be 39. So there's 39 people who are between ages 24 and 30. And so the very next person who is in line, who is going to be at age 31, is the median age. So it's 31. Then they say find the 65th percentile. So I do this a very similar way. I just do 65 over 100 times 79. Well, that's going to simplify to 0.65 times 79. And we're going to get 51.35. And that is going to round to 52. So we need to find the 52nd person in line. We just found out that all the people up that were aged between 24 and 30, those were the first people in line, they added up to 39. You can barely see it down there, but it's 39. So if I add another 13 to that to include these people, that would be 52. So that person is going to be the last person who is the 52nd person in line is going to be the last person who responded 31. They are 31 years old. So the 65th person is 31 years old. All right, then let's find Q3. Q3 is the 75th percentile. Find the third quartile, or Q3, which is 75 over 100 times by 79. So that's 0.075 times by 79, which is 59.25, which rounds up to 60. So we need to find the 60th person in line. We already know that that when we include the people who are age 31, that was 72 people. Or 52 people, if I add 7, now I add the number of people who said 32, then I'm going to get 59. So that tells me that the very next person is going to be the 60th person in line, and they're going to be of age 33. So 33. Then they ask, what is the maximum age? Well, that one's just as easy as the smallest age. Because these ages are all listed from smallest to greatest. 38 is the last one. And it is the greatest number of all those ages listed on the table. So 38 is our max age. What is the range? So the range is always our largest data value, which is 38, minus our smallest data value, which is, so that is, looks like the range is 14. All right, then the interquartile range, remember that's Q3 minus Q1. And our Q3, as we saw from above here, is 33. And our Q1 is 29. So that has a difference of 4. So our interquartile range is 4. All right, that's that problem. 800 insects were weighed, and the resulting measurements in milligrams are summarized in the box plot below. They ask us, what is the range of the weights? Now, remember, I let you guys know that usually these whiskers, they go from this first quartile, Q1, and the whisker will go all the way down to the smallest data value if it's inside the lower fence. If there was a data value that was smaller, it would be that's outside of the lower fence and considered an outlier, which is like an outlier is a data value that's extremely different than all the rest of the data values. Most data values will be like, so it's like, if everybody scored around 70% on the test and one person scored like 5%, that person's like an outlier. They're very different than most of the data. So if you had an outlier, it would look like that, like a little asterisk on the graph. And that value, wherever it is located on the number line, that it represents a data value, and it would be the smallest data value. The one that's furthest to the left, the little asterisk or star, sometimes it's drawn, or like a little cross kind of thing. It would be the smallest data value. However, I don't see any asterisks on this graph, so I'm going to assume that where these end, that is our min and max values. So I just draw this down to the number line to like kind of really see what it is. And it looks like it's landing right in between 100 and 110, so it's 105. And then this one, I draw it down, and it looks like it's like one right above 145, so 146. So the range of weights is 146 minus 105. Because this is which is 41. All right, and then what is the interquartile range? That's Q3 minus Q1. And like I said, these, when I was introducing in 15.2, the this box plot, I mentioned that these 3 vertical lines that are involved with this box, inside this box here, that's our Q1, this is our Q2, also called the median, with a big M, and this is our Q3. So I just had to figure out where these appear to end. This seems to be like at 114. And then this one I would say that's 126. So we'll do 126 minus 114, and that is our interquartile range. Is 12. And there we go. Well, let me know if you guys have any questions. Have a great day. Bye.